Hello, and welcome to DevOps Quick Bites, your friendly guide to all things Salesforce DevOps with me, Rob Cowell. In this episode, I want to talk about Salesforce testing in all its glorious forms: Apex testing, Lightning Web Component testing, and flow testing. So if that sounds like something you'd like to explore more, stick around. So to kick things off, let's take a look at Apex testing, the most common type of Salesforce testing that you're likely to encounter. Apex tests are units of code that will pass or fail depending on the logical branches and outcomes of your Apex classes. This is crucial for maintaining the code health and ensuring that any new changes don't break existing functionality. Now, when we talk about Apex testing, we're discussing a few main types of tests. We want to look at positive and negative flows, i.e. testing things that are successful and that things are not successful but handled correctly. But also we want to make sure that we're testing records in isolation and in bulk. Let's have a look at this in practice with some example Apex tests. To demonstrate Apex testing, we're going to use this very simple order processor class that acts on a custom order object. Here we can see we get a list of orders and we validate them with this method here based on the amount, and we mark whether or not they're processed. Very simple for our test. Speaking of the test, here is our test class. And there's a few key things that indicate best practice here. Firstly, we mark it up as a test, fairly self-explanatory, so that the system knows that it is a test class and doesn't count towards code coverage. Now, the next thing that we do here is we set up our test data. We should never use real data for testing because it may not exist in other environments. In order to remain within Salesforce's limits, we use a test setup method, and that allows us to have our own unique set of limits for setting up the test data independent of the tests themselves. So we add some orders that meet the criteria, and we add some orders that don't meet the criteria. And this brings out a very key point. It's always important to test both positive and negative flows. So test when things work, but also test when things don't work, that they're handled correctly. Now, another aspect of this, as we look through the code here, we have our positive test and our negative test, as just explained, but those are only testing one single order. You can see here we have limit 1. Okay, we're limiting our list of orders to just one record. But in the real world, that doesn't always happen. What we need to do is test for bulk to make sure that it can handle when it receives a longer list. So again, we do our positive test and our negative test, but this time we're looking at bulk processing. So we're not limiting our query, we're selecting all of the records that meet that criteria. And again, we're testing to make sure that the status on those positive orders is set to processed. Okay, we're doing an assertion. And the same with the negative tests. We're making sure that they are not equal to processed, i.e. they haven't been set because they don't meet the criteria. And that's, at a high level, the very basics of an Apex test. Using an IDE such as Visual Studio Code with its Salesforce extensions will significantly streamline the writing, running, and debugging of your Apex tests. And remember, while we have a minimum of 75% coverage in order to deploy them, you really want to be aiming higher than that to make sure we have truly robust applications. Now let's switch our focus to something equally essential: testing Lightning Web Components, or LWCs for short. Testing LWCs is about verifying that your components not only display data correctly, but also handle user interactions or unexpected behaviors seamlessly. Imagine you've crafted a component that updates the status on your orders. You'll want to be certain it performs well, whether it's retrieving data successfully or neatly handling any errors that may arise. To handle these tests, Gest is our go-to framework. It's perfect for simulating user interactions such as clicks and input and checking the outcomes. With Gest, you can mock data, which allows you to test your component under different scenarios. So let's revisit the code for an example of some Gest testing. So coming back to our Visual Studio Code examples, I've got a Lightning component here called Order Status Updater, and it's simply a button and a drop-down box that allows you to update the status from either pending, processed, or cancelled. Very straightforward, and it sits nicely on the page. But like everything else, we need to test that that actually works. So again, we move into testing. And here we have a test written in Gest, which is an extension library for testing JavaScript. And there's a few little bits of setup that we need to do here. One of the key elements that we need to cover in this is mocking a record. So mocking is effectively generating fake data. So again, we're not depending on actual data in the system to generate our tests and operate our tests. So there's a little bit of setup around that. Using this get record emit, we get that mock record. Now that record is defined in a JSON file, and it basically mirrors the structure of a sample order record so that we can use it for our testing. But the key thing to this test is much like the Apex tests. So ignoring all the setup that is required here, the key elements are we are checking that it updates the order status correctly when the save button is corrected. So we run some code that gets that record, and then we simulate that change. So we select our Lightning combo box down here, and this is very much like you would do within the user interface, but we're kind of programmatically cheating a little bit. We are dispatching an event of type change. So effectively we're saying, okay, this has changed, process it now. And we're specifying that we've set the combo box value to processed. And then we click the button. So this is very much like some of the automated testing tools you may have seen where you can record your mouse actions and it'll follow and it'll click and you'll see that type of work. We're just doing that programmatically. Now, the reason we're doing that is it becomes much easier to integrate these type of tests into scripts when you're looking at CI/CD workflows, for example. So much like our Apex tests with our assertions, in Gest tests, they're called expectations. So we expect that button label to be set to update status. Now, in this scenario, that's just one of the things we'd test. We'd actually be expecting the value of the record to change, but I leave that as an exercise to the reader. But effectively, you can test the value of any of your fields in there, much like you would do with your assertions, and just make sure that your logic makes sense. Lastly, let's talk about Salesforce flows. Now, because they can automate complex business processes, just like code, you should be testing them just like code. Now, while Salesforce does provide a debug run feature that lets you step through your flow in the Flow Builder interface and expect each element's behavior and output, the challenge with testing flows is that they fall a little short of what you get with code testing. The flow testing tools require manual setup for each test scenario, which is quite time-consuming and error-prone, especially as your flows and your processes get more complex. And there's no way to automate those tests from within Salesforce itself, which means you don't get that consistency. Every change or update, you're back to changing and manually testing those flows. It's definitely not ideal for those large or frequently changing workflows. But most critically, flows use real data to test, records that might not exist in your upstream environments. And that's equivalent to hard coding IDs in your work, definitely something that we want to avoid. So for now, Apex remains the best way to test flow functionality, ironically. You can run operations that trigger your flows, or should do, and check for expected and unexpected outcomes. Let's explore that a little in practice. So, once more into Visual Studio, and we've got our class here that's going to test our flow. So much like our Apex tests, it will set up the data that we need in order to be able to validate our process. So again, we have our test set up to make sure that everything is within the limits, and we create the orders. Now in this scenario, we're going to create some high value orders. We're going to create some low value orders. And again, the reason for that is our positive tests and our negative tests. So again, we're also checking single records here. So we're testing a positive single record and making sure that when we update the order, the flow will trigger. How do we test that? Once again, we use an assertion. We're looking to make sure that the order status has been updated to processed. We have our negative test. So we select the record that doesn't meet the criteria for entry into the flow. And we make sure that the order status is not updated to processed. So you can see a pattern developing here, much like we did with the Apex tests. We're effectively using the same techniques, but we're just checking that the flow is doing the update and making sure that the status is as we expect. So we do the same with bulk orders. We make sure that those are updated correctly. And then we do the same with a mixture. Now, this is quite an important thing to bear in mind as well. You may have a bulk list of orders that are going through. Some meet the criteria, some don't. And so really we want to be checking that. And this is where the real skill in writing your tests comes. It's not in the actual coding. It's in actually applying logic and thinking through what are the scenarios that could happen and making sure that you check what happens when they do. Testing in Salesforce, whether it's Apex, Lightning Web Components, or flows, is an indispensable part of the development process that helps ensure that your applications are not only functional, but also efficient and user-friendly. By adopting these testing best practices and using the right tools, you'll elevate your Salesforce development to new heights, ensuring robustness and reliability across your org. Now, I appreciate this hasn't been the quickest of our quick bites, but hopefully it's been useful enough to keep your attention. In the description below, you'll find links to resources around this topic, including a Git repository of the examples that I've used for this session, and a link to a new testing course that covers many of the things that we've covered here to really prove your skills in this area. So be sure to check those links out. If you liked what you hear, be sure to click the subscribe button below for next episodes of Quick Bites, and stay tuned for more of our insights where we explore other aspects of Salesforce development and DevOps. Until then, happy testing and keep on innovating.